and welcome to Proving the Concept, the podcast where we delve into the weird, the wonderful, and sometimes downright bizarre world of science and technology. I'm your host, Sarah Goffin, and today's episode is packed with intrigue and discovery. We're diving into the world of X-rays, an invisible force that transformed our understanding of the world, from the human body to the atomic structure of molecules. Our episode, cheekily titled X-rated, will explore the history, science, and surprising applications of X-rays and X-ray crystallography. We'll also discuss how this technology shaped modern medicine and highlight the contributions of a pioneering female scientist within this area. So, whether you're a science geek, or just a curious mind, or just someone who loves a good story, stay tuned. Start in 1895, where Wilhelm Conrad Röntgen accidentally discovered X-rays. Röntgen was working with cathode rays when he noticed something strange. A fluorescent screen nearby actually started glowing, even though the cathode ray tube was shielded. Curious, he explored further and found that these mysterious rays were able to pass through solid objects and produce shadow-like images. The first X-ray he captured was his wife's hand. This grainy photograph, complete with wedding ring, astonished the world and marked the birth of a revolutionary technology. Röntgen coined the term X-rays, with X signalling the unknown. This discovery was so transformative that Röntgen received the very first Nobel Prize in Physics in 1901. And here's a fun fact for you. Röntgen refused to patent his technology because he believed his technology should benefit all of humanity. Imagine if he hadn't, how different science and medicine would be today. At their core, X-rays are a form of electromagnetic radiation, like light or radio waves, but with much shorter wavelengths and higher energy. These properties allow X-rays to penetrate materials that visible light can't, such as skin and muscle, while being absorbed by denser materials like bone and metal. The absorption difference is what gives us the characteristic black and white images. The dense structures appear white, and softer tissues show up in varying shades of grey. In medicines, X-rays are more than just imaging bones. They're also used for diagnostics for areas such as the lungs and other organs of the body. In dentistry, X-rays are used to identify dental health issues. In industry such as aerospace and construction, X-rays are used to identify flaws in machinery. And in art and archaeology, X-rays reveal hidden layers of paintings, like sketches beneath famous works, and inspect ancient artifacts without damaging them. Now let's take a break from the technical stuff and talk about some fun and exciting facts about X-rays. In the mid-20th century, shoe stores used X-rays to measure people's feet. While it seemed futuristic at the time, prolonged exposure was actually detrimental to health and led to this practice being banned. Did you know that NASA's Chandra X-ray Observatory studies cosmic phenomena such as black holes? These powerful X-rays tell us more about the extreme environments out in space. And finally, X-rays are extensively used in airport security to make sure that individuals aren't bringing problematic substances or items through onto planes. And here's another fact for you. Did you know that during the Second World War, X-rays were actually used for espionage? Agents used portable X-ray machines to scan packages without opening them. Science meets spycraft. Now, let's talk about X-ray crystallography, an advanced application of X-rays that revolutionized molecular biology. Here's how it works. When X-rays are aimed at a crystal, they scatter in patterns reflective of that crystal structure. By analysing these patterns, scientists can map the arrangement of crystals within an atomic structure. Notable discoveries in this field include the DNA double helix structure, for which Rosalind Franklin's X-ray crystallography was paramount in this discovery. Penicillin's structure was determined through X-ray crystallography, leading to better drug development. In addition, vitamins B12 and insulin were also identified looking at X-ray crystal structures. From developing new drugs to designing better materials, X-ray crystallography remains essential across industries. And it's not just for crystals anymore. Modern techniques allow scientists to study proteins and other complex molecules in action. Let's end by celebrating Dorothy Crowfoot Hodgkin, one of the most remarkable figures in science. Born in 1910, Hodgkin developed a passion for chemistry and X-ray crystallography at a young age. Despite facing significant barriers as a woman in science, she persevered and became a pioneer in her field. Going back to our earlier stories, Dorothy Crowfoot Hodgkin was paramount in being able to identify the crystal structures of many drugs that we still use today, such as penicillin, vitamin B12, and also insulin. Her work on vitamin B12 actually earned her the Nobel Prize in Chemistry in 1964. Now, despite her Nobel Prize recognition, Hodgkin remained humble and was dedicated to mentoring the next generation of scientists, particularly women. She often said, "I was only doing what I loved." Her story is a reminder of the value of perseverance and the importance of women in science. So, what's next for X-rays? Advances in technology are pushing the boundaries of what X-rays are able to achieve. X-ray lasers are enabling ultra-fast imaging of molecular dynamics. Portable X-ray devices are making diagnostics easier in more remote regions. And in addition, AI-powered technologies are helping improve the speed and the accuracy of X-ray interpretation. The potential of X-rays seems limitless, from exploring the smallest molecules to unraveling the mysteries of the cosmos. And that's it for today's episode of Proving the Concept. We've journeyed through the history, the science, and surprising uses of X-rays and X-ray crystallography, and celebrated the incredible Dorothy Crowfoot Hodgkin. Thank you for joining me on this adventure into the invisible. If you enjoyed this episode, please subscribe, share, and leave a review. You can also follow us on social media for more science stories. Until next time, keep questioning, keep exploring, and keep proving the concept. Bye for now.